So now we're going to talk about something called a row operation. And this is yet another way to get a linear system solved. So now we're up to 6 ways. But this particular method is kind of a repackaging of elimination. Okay. When you eliminated in a 2 by 2 system, you multiplied one of the equations by a variable and then you added, correct? So, what we call elementary row operations is just elimination. It just sounds fancier. Okay, so our elementary row operations are the following. Okay, the first one is we can switch a row. And basically this is just moving rows around. And if you're having trouble kind of seeing what I mean, once we tackle this system to the left, you'll kind of see what's going on. Okay. The second row operation is multiplying a single row by a scalar. Okay. And then the third is we add 2 rows together to create a new row. Now what happens is these two, number 2 and 3, these can be combined to kind of make your life go a little faster. Okay. Now the goal of elementary row operations is to get your system, okay, to look a certain way. So what we're aiming for is to rewrite the system so it is in what we call row echelon form. Okay. Or even better, but it takes a little bit more work, reduced row echelon form. Now, if you've got a TI um, TI 84 plus calculator or any of the graphing calculators, um, what you will find is if you go into the matrix menu, um, you will see that it does have a reduced row echelon feature on it. I don't have one of those, so at least not right now. So you might have to figure it out. Okay. All right. So row echelon form looks like this. You're gonna have ones down the main diagonal, and then your augmented matrix like that. Okay. Reduced row echelon is even cooler because in your augmented matrix that we're going to write, you actually have the identity and then you have a bunch of numbers here. Okay, when you get your system to row echelon, then what you do is solve the system by back solve. Once you get it to that point. Okay. Now, if you get it into reduced row echelon form, your system's solved. Okay. Now, these are also called Gauss or Gauss elimination or Gaussian Jordan elimination. So if you hear somebody drop those phrases, this is what they're talking about. Okay, so let's try one of these out. These, again, like Kramer's rule, if you're doing these by hand, there's lots of room for little errors. Okay, but we're going to solve this system on our left using elementary row operations. Okay, we'll probably just take it to row echelon form and not reduced row. Okay, so first thing you have to do is you have to rewrite this matrix as an augmented matrix. And an augmented matrix is simply the coefficient matrix with the the constant matrix just immediately to the right. Okay, so we're going to get rid of all the variables and such. I like to use a line, but you don't have to. Some people use dots. Okay, so there's our augmented matrix. Okay, so Edgenuity says that they like the row with the largest leading coefficient on the bottom, which is fine. I don't know why, but up to you. I do like having a leading one on the top. It kind of makes life easier. So what we're going to do is we're going to switch row 2 with row 3. So basically these are going to change places. So my new matrix will look like this. Row 1 didn't change. But row 2, whoops. Okay, so I just literally flipped the rows. Okay, so now what I want to do is I want to go for row echelon form, which means this 4 has to turn into a 0. So what I'm going to do is I'm going to multiply row 2 by a -4 and then add it to row 3, and that's going to give me a new row 3. Okay. All right. So, and you can do like little tiny scratch work. Like if you multiply this by -4, and then we're going to add. So add. Okay. Again, row 1 stays the same. Okay, now here's the tricky part. Row 2 stays the same. This is all about changing row 3. So 0, -11, 17, and then 11. Okay. All right, so now I like to build zeros first. Okay, so now what I want is I want to make a new row 2. So I'm going to take row 1, multiply it by a -1, and then add it to row 2 to get a new row 2. So 1, 2. that, and then add down. Okay, so row 1 stays the same. Row 3 stays the same. Okay, so now I'm going to have to start building some more zeros and ones. So there's a couple of different ways I can do this. I've got some choices. Since I have so many odd numbers, this could be a little tough. Let's see, what could I do? And hopefully I didn't make a mistake. Again, mistakes on this are not fun. Okay, I'm just, because I'm paranoid here. Okay, just making sure. Okay, copy everything down right. Okay, so let's see. I want to create. So let's do this. Let's multiply by a scalar, row 3. So I'm going to multiply row 3 to get a new row 3. Just like that. Okay. Now, what I'm going to do is I'm going to switch my row 2 with my row 3. Okay. Now, what I'm going to do is I'm going to multiply row 2 by a -5, add it to row 3 to get a new row 3. Okay. Good thing I have a calculator. Okay, here we go. Okay, I know you're probably sitting here thinking, oh my gosh, this is so annoying. I always thought of it like a puzzle. That's just me. I kind of like puzzles. And I am using my calculator. Now, We're almost there, believe it or not. We're not in row echelon form yet because this is not a 1. So to be in row echelon form, you need to have that a 1. So what we're going to do is we're going to multiply row 3 by the reciprocal, and we're going to get a new row 3. Okay, now I've got this. Okay, now what this tells me is I have this. I have x minus 2y minus 1 z is equal to 4. Then I have y minus 17 over 11 z is equal to negative 1. And then I have z is equal to 0. So right now I know who z is. If z is 0, then y minus 0 is equal to negative 1. So y is equal to negative 1. Okay, if y is equal to negative 1 and z is equal to 0, then let's go up here. X plus 2 is 4, so x is equal to 2. So once you get it into row echelon form, you just kind of, the solving by back substitution is actually very quick. Okay, so yeah, that took a while. Yeah, that was a little tricky, but it's a little doable and it's kind of fun. Okay, but again, I'm a math teacher. I think this stuff is fun. Okay, you just got to remember that this is just the elimination stuff that you did in Math 1, Math 2, Math 8. Okay, all right, thank you.